welcome. So by the end of this lesson, you will be able to do like linear interpolation and do regression analysis with Excel using Excel Trendline and using Analysis ToolPak, and then you will be able to use this equation to make future projection. So this is the example. This is the change of Earth's temperature with time, and you can see like there is an upward trend, which means that the Earth's temperature is rising. And if I want to use this trend to make a future projection, one way to do this is like, for example, to extrapolate. So I can extrapolate to the mid-century, 2050, for example, or end of century. So how to do this? Like, so you can find like the slope here. So that's like your first point, and the like your last point here. So you find the slope between these points, or like it could be any point, and then you extrapolate it to here, or like extrapolate it to here. So how to do this extrapolation? So linear extrapolation, you find the slope, you multiply it by distance, and then where you started from. Okay, that's the equation. So for example, so let's find this. So I want to project this to 2050 and to 2100 to extrapolate. So I found like the slope. So how to find the slope? So that would be my delta y, okay, over delta x so now that's the slope, and over what distance do I want to do this? So I wanted to do it until 2050, so that would be the value here. That would be like a 75 minus wherever I'm starting from here, okay? And then I want to add it to whatever value here, like not start from 0. So add this here. Then I got like about 1.3, that's mid-century, and then I can drag it here, but let me fix these things. Remember, that's how to make like, so we want to fix the slope like this, where it's the starting point and the slope. I want to fix all this, and here's the starting distance. This is the only one that I want to change. Distance here is like, I mean distance on the x-axis, like time interval. So if we did this, we got about 2. Okay, so did I do everything correct here? Oops, no, I didn't, because let me just do it again. I didn't do it. Okay, so fix the slope. Okay, I only just like here. I just want to use the same slope, which okay. And like whatever I did before. Okay, so if you drag here, it's like, yeah, same answer. So basically, this is like what I did. Like I'm saying, like if I like whatever trend I have between my first point and last point, like whatever slope I have, I will just extend it. So if I extended this slope to the end of century, I should be, yeah, around somewhere around here, which is just exactly what I got. Okay, but this is not smart. I mean, this is not the right way of doing this, because if I just made this slope based on just the point before the last, I will be, and I extended this, I will be here. Okay, so a better way of doing this is like to fit like a regression line to this. Basically, the regression line, it is lines that try to minimize the residual, like that is the distance between your observation and your prediction. So here, let me just show you, like, so So here, for example, like this, so, and not only for one point, for all the points. I want to basically like reduce this distance from here to here, from here to here, like to make these points as close as possible to this the fitted line. That's what I want to do. Make these points as close as possible to the fitted line, and that would be like through like minimizing the residual. So here is just like an example of linear regression, and in linear regression we usually determine this by I square, R square, so R square, so that's like my line here, that's my observation, that's the distance between the line and the observation which I want to minimize. So that is the sum of the square like residual, and reference this to like the mean, like if there was no trend, like the mean value, so I subtract this from the sum of the square like total, and then I divide by the sum of square total, and that would be my R squared. In other words, if like this distance is 0, then S sum of the square total and sum of square total will be 1, which means that this line perfectly fits the observation data. If on the other hand, if this is totally random, there is no trend, we don't have any trend, then this sum of the square residual will be equal to the sum of the square total, like would be equal to the mean here, and then you divide like this one, like, so that would be like 0, and then you will get like your R squared would be 0. This means that you don't have any correlation, as this is like pure random. Okay, so so how to do this? Like the easiest way to do this actually in Excel is that you come here, you add a trend line, and then it will tell you like you select linear, display equation on chart, display R square. So now here I have like my trend line, and that's like the equation of the straight lines that I fitted to the chart. Let me increase it here. Oops. This is the slope. So that's like the slope of this line here. Okay. So the slope is like this or like that. And this is the intercept. Basically means like if I extended this line all like the way down, like where x is equal to 0, that would be the temperature. Okay. Now one thing we can do, like if I want to use this relationship to do like to extrapolate this to 2050 or end of century, I can just like type this equation, and then I can extrapolate it. But here I might want to show some so let me do this one. I want to format this label, I want to make it number, and then I want to put more decimal points. Just want to make more decimal points to my equation here. It's not showing. Okay, do it again. So I add a trend line. Set. Okay. I come here. I make this. Okay. And I want to add more decimal point to this one, so I select number and let's not showing. Let's do it again. Link to source. So I want this to show here, like the equation here too. Okay, so let's remove this. Move this one. Come here. Add the trend line. Number, and then I add decimal point. Okay, now I'm showing more decimal point here. Okay, come here. Because you see, I want the slope to be as accurate as possible, and then what I can do, I can copy this, Control C, and then I can paste it here. Just type it 0.001507 times x, which is this is my x, minus 29.6186. Okay, so I got like this value, and then I can extrapolate it all like the way to here. Actually, it's not very different from my interpolation value. I can add this to the chart. So let me add this to the chart. Select data. So I want to add. I call this like my model. Select the X range. That would be from here to here. I will select my Y range. Be from here to here. Then I select this my first model, and then usually for the model of the fitted line, we usually show this as a solid line. Data is usually dot, so here you come and select the solid line. Okay. So basically, this is the best lines that I could fit to the data. Another way to do like the same thing is that you can use Excel data analysis tools. So how to, if you might not find this on your screen, like how to add this to your screen, like you come here, I think you go to options, and then you go to add-ins, and then from add-ins you can find like whatever you want to add in. Like I already added it, like you add solver, you add analysis ToolPak, and then you click like OK, and then you should be able to add this. So, and then you will find this here. So like you come here, you select it, and then this is the analysis that you want to do. You select like regression. It tells you what's your Y range. So it's just like my data points here, like up to here. What's your X range? So that's like my X axis, like my time value here. And then I'll put this like you want to put the regression analysis. This is, let's call it like 1950 exercise, like regression. Okay, and then here it did like the regression for you, give you some information about this regression. Here is like the R square, for example, and these are your coefficients. So that's like your intercept, and this is like your slope. So same thing, you can, if I want to like make like these like projection here, I can just use the same thing. So I come like here, So that's like my intercept. Okay. So let me do it this same way I did here. So I put like x, find my slope. So that's like my slope here, plus my intercept. Okay. So I got like the same. Okay, now you see like I should fix these numbers like this. A I want to change, but I want to fix these guys. So I don't. So like I fix this one, and I fix this one again, and then we do this, and we got like the exact same answer. My r square, like see, like we got like the exact same answer. So let's put this value that we got here. So like we got the slope here. Let's go from the regression, like this, the slope we got, the r square, where is to, like we can put, see, r square here, and then I can do this like numbers that I projected. This one and the numbers that I projected. I will tell you in a minute what is this table. The number I projected, that would be this one. So basically this table, like I have two models here. Model number one, I'm using data from 1880 to present. Model number two, I am using data from 1950 to present. And you see the rate of change, the slope of the temperature increase. If I included like only the recent data, it's going at a much faster rate than the old data. And that's, you get a better correlation, because like now like you are not like considering like two slopes, and then and you see from, if I use like the full data set, the end of century projection would be 1.2, versus if I use like only the most recent trends, the end of century projection would be 2. And this shows you like how this regression analysis is you need to use it with care, because this is basically what this is telling you, like giving this a slope. All I'm doing here, like I'm having a data, I'm fitting a baseline to this data, and I'm saying like giving this a slope, that would be the value in mid-century, or example, or end of century. Just giving this slope, but this slope, is not constant, as you see like across time, because the climate forcings are changing. And that's why when we do this projection, we generally don't use like this data-driven model, but we use like a climate model, which is like a physics-based or a mechanistic model. Okay, that's all.